now this is for 5th grade. I will be teaching you about exponents using Eureka Math. So area models really don't get in here that much, but place value charts still stay in there because they are so annoying. So let's start with basic things like, 10, 100, and 1,000. Fun fact, they're all divisible by 10, so they end up being 10 to the first power, 10 to the second power, and 10 to the third power. Pause this video right now if you've ever learned about exponents. Exponents say how many times you multiply the number by itself, except 0, which ends up the number as 1. So 10 to the 0th power equals 1. Okay, so 10 times nothing equals 10. 10 times 10 equals 100. And 10 times 10 times 10, which is 10 to the third power, equals 1,000. So 10 to the third power is equal to 1,000 because it's 10 times 10 times 10. That number up there tells you how many times you multiply the number by itself. And make sure it is smaller than the bigger number. Make sure the exponent, let me make you a chart. This is the number. And this up here is the exponent. Size it about 1/3 to 1/5 smaller than the number. So it needs to make sure because teachers will say, if someone does it like this, oh, it's 32, he got it wrong. It's supposed to be 3 to the second power. Anyone who does that, just don't do it. Make it small like this. See, that is much better than that because that looks like a 32 in a slant, not that. If you're going to do it like that, at least make it straight so it's semi-clear. But try your best to have a perfection number like this. That's what exponents are. Here are some more example problems of it. So like examples. So let's say 3 to the third power. I don't know this myself, so I'll have to do it myself. 3 times 3 equals 9. Times 3 equals 27, I believe. So 3 to the third power equals 27. Is that right? Yes, I believe it is. So that's how you do it. You don't do 3 plus 3 plus 3 plus 3. Beep. Ching, that is right. This is also wrong. 3 times 3 times 3 times 3. So you do it 3 times because of the exponents, then you do it an extra time because of the 3 there. That is wrong. Do it like this. 3 times 3 equals 9 times 3 equals 27. Any other crazy ideas, please put it in the comment section, and I will say if it's right or wrong. It'll probably be wrong, though, because that is pretty much the only way to do it. Another right way to do it is 3 times 3 times 3. Of course, this doesn't apply for all problems. This applies for 3 to the third power. For example, 1 to the third power equals 1 times 1 times 1. Not anything else. 1 times 1 equals 1 times 1 equals 1. 1 to any power will always equal 1 except, well, yeah, everything, even 1 to the 0th power. So exponents are like that. A function, they tell you how many times you multiply the number by itself. Not anything else. Oh, also one more way that it's wrong. Don't do this. So let's say 42, 4 to the second power. It is not 4 times 4. Well, actually it is. What I'm trying to say, it's not 4 times 2. It is 4 times 4. Beep. Fail. Ding, ding, ding. So make sure you do it right, please. Because I would like you to get a low report card. Because then you'll say, oh, I blame it on the YouTube video I saw. Well, no, I'm making sure that does not happen. Okay, so this is a 5th grade problem. 0.01 times 10 to the 3rd power. Here's another trick if you are too lazy to figure out what 10 times 10 times 10 is, which equals 1,000, by the way. You can just add that many zeros to this. But actually, here's what happens when you do something by 10. And it's kind of weird. So the decimal actually moves. So you move it if you're doing multiplication, the decimal will move 3 times to the right because it's 10 to the 3rd power. 3 times. 1, 2, 3. Add a 0. And you get instead of this, you get 10. So let me see. No, it's 1. Did it wrong. It is 1. So let me redo that. Bam. It's 1, 2, 3. Wait, what? It's confusing. Anyway, I have to check on that, but yes, that is a way to do it. So, yeah, it is 10. Okay, so here's how to do it on a place value chart. So this represents tenths, hundredths, and thousandths. See these points? They're the decimals. So you put 0.01 on the top, make sure they're right, and then since it's time tenths to the 3rd power, you move it up 3 times. 1, 2, 3. And 1, 2, 3. So you just add in with zeros, cancel out that 0 because it doesn't matter. So you get 10, so apparently I was right. In this, if you multiply, you move to the left. Left. If you do this, you move the decimal to the right. If you do it like this, add zeros, 0.01, add zeros, 1, 2, 3, get rid of the point, and get 10, you move the number to the left. So if you're moving decimal, DEC is right, and noob is left. NUM stands for number, and DEC stands for decimal. If it's decimal, move to right. Numeral, move to the left. Place value chart, move to left if you're multiplying. This is for multiplication only. Do not try the same thing with its inverse operation, which is division, or you will mess it up. Honestly, I wouldn't like you to do that. So, for division, it would be reverse. Instead of moving this to the left, it would be to the right. This would be to the left, and this would be to the right, so it's inverse, opposite. And you can do the same thing with this. So let's try its inverse operation on the same basic question. Okay, so this is 1, this is 10. Here's how I like to do it. This is just me. You don't have to do this. 0.01. It doesn't matter if you have a 0 here. It doesn't matter if you have 0.1000000000000. It doesn't matter. You can X out all those zeros. They don't matter. As long as the zeros are behind all the numbers that are over 0, but this wouldn't apply. You wouldn't get rid of a 0 in here. If it's past the last number, If the zeros pass the last number, you can get rid of them. These don't matter right now. I don't care about those. It can go on forever. You can have infinity zeros. Still doesn't matter. And you always do have an infinity zeros, but you just don't write them. So let's have its 10 counterpart. So let's have 110. Well, 110. And then you divide it by 10 to the third. So you move this back 1 space, 2 space, 3 space. Point 0.01. And you fill in that 0. Do not get rid of that 0. That 0 is important, unlike these that go after those. But here's how you do division, like this. Division. You'd move it to the right this time. So R, when you're moving decimal, and right when you're moving number. RLR. Remember it like that. Move this. And that is the end of my video. I will see you next time.